Volcanoes have long captured human imagination with their raw power and devastating potential. Throughout history, they have shaped landscapes, influenced climates, and even altered the course of civilizations. The question of whether volcanoes could bring about the end of the world is both intriguing and unsettling. To understand the potential impact of volcanoes on a global scale, we need to explore their mechanisms, historical precedents, and the possibility of future catastrophic events. Volcanoes are essentially vents in the Earth's crust through which molten rock, ash, and gases are ejected. They are found primarily at tectonic plate boundaries, where plates either converge or diverge, but they can also occur at hotspots within plates. The scale of volcanic eruptions can vary dramatically, from relatively benign lava flows to cataclysmic explosions that release vast amounts of material into the atmosphere. One of the most significant ways volcanoes can impact the world is through large-scale eruptions that release massive amounts of ash and sulfur dioxide into the stratosphere. These particles can spread globally, reflecting sunlight and leading to a temporary cooling of the Earth's surface. This phenomenon, known as volcanic winter, can disrupt weather patterns, reduce agricultural yields, and trigger food shortages. The eruption of Mount Tambora in 1815, for example, led to the Year Without a Summer in 1816, causing widespread crop failures and food shortages in the Northern Hemisphere. The potential for even greater destruction lies with supervolcanoes. These are volcanic centers that have the capacity to produce eruptions of magnitude 8 on the Volcanic Explosivity Index, VEI, ejecting more than 1,000 cubic kilometers of material. The most well-known supervolcano is the Yellowstone caldera in the United States. The last major eruption of Yellowstone, which occurred approximately 640,000 years ago, covered much of North America in ash and had global climatic effects. A supervolcano eruption would have devastating consequences. The immediate impact would be catastrophic, with pyroclastic flows, widespread ashfall, and toxic gas emissions causing massive loss of life and destruction of infrastructure. The long-term effects would be equally dire. The injection of ash and sulfur dioxide into the stratosphere would likely lead to a significant cooling of the Earth's climate, known as a volcanic winter. This could last for years, causing severe disruptions to global agriculture, leading to food shortages, economic collapse, and societal unrest. The Toba supereruption, which occurred about 74,000 years ago in present-day Indonesia, is believed to have been the largest volcanic eruption in the last 2 million years. Some scientists suggest that it caused a global volcanic winter that lasted for several years and may have resulted in a genetic bottleneck in human populations, reducing the number of humans to as few as 10,000 individuals. While this theory is still debated, it underscores the potential for supervolcanoes to have profound impacts on life on Earth. Another way volcanoes could potentially threaten global stability is through their influence on climate change. Large-scale volcanic eruptions release significant amounts of carbon dioxide, CO2, a greenhouse gas, into the atmosphere. While the immediate cooling effect of volcanic ash and sulfur dioxide can temporarily offset global warming, the long-term release of CO2 could contribute to climate change. However, it is important to note that human activities currently release much more CO2 than volcanic eruptions. The real danger lies in the possibility of multiple large eruptions occurring in a short period, amplifying their climatic impacts. Despite these dire scenarios, it is important to recognize that supervolcanic eruptions are extremely rare. The likelihood of a supervolcano erupting in the near future is low, and scientists are continuously monitoring known supervolcanoes for signs of increased activity. Advances in geophysical and geochemical techniques have improved our ability to detect early warning signs of volcanic unrest, such as ground deformation, gas emissions, and seismic activity. Furthermore, humanity has demonstrated remarkable resilience in the face of volcanic disasters. The eruption of Mount Vesuvius in 79 AD, which destroyed the Roman cities of Pompeii and Herculaneum, was a tragedy, but it did not end Roman civilization. The eruption of Krakatoa in 1883 caused tens of thousands of deaths and had global climatic effects, but it did not bring about the end of the world. These examples show that while volcanic eruptions can cause significant regional destruction, they have not historically led to global annihilation. However, It would be naive to dismiss the potential threat of volcanoes entirely. As the global population continues to grow and urbanize, more people are living in close proximity to active volcanoes. This increases the risk of large-scale disasters with significant humanitarian, economic, and environmental impacts. Developing comprehensive disaster preparedness and response plans, investing in early warning systems, and educating communities about volcanic hazards are crucial steps in mitigating these risks. Yet, as we marvel at the geological forces that shape our world, we must also acknowledge the potential risks they pose. Volcanic eruptions are not just natural phenomena. They are reminders of Earth's dynamic and unpredictable nature. Understanding their mechanisms and historical impacts can guide us in preparing for future scenarios. In recent decades, advancements in technology have transformed our ability to monitor volcanic activity. Satellite imagery, remote sensing, and ground-based sensors provide real-time data on volcanic gases, ground deformation, and seismic activity. These tools enable scientists to detect early warning signs of volcanic unrest, giving communities valuable time to evacuate and prepare. However, preparedness goes beyond technology. It involves educating communities about volcanic hazards, establishing evacuation plans, and building resilient infrastructure. The devastating eruption of Mount Pinatubo in 1991, for example, led to the successful evacuation of thousands of people in the Philippines, minimizing casualties despite the eruption's intensity. Moreover, international collaboration is essential in mitigating global volcanic risks. Organizations like the United Nations and the World Health Organization coordinate efforts to share knowledge, resources, and best practices in disaster response. This global cooperation strengthens our collective ability to respond effectively to volcanic emergencies, protecting lives and livelihoods worldwide. As we look to the future, scientific research plays a crucial role in enhancing our understanding of volcanic behavior and potential hazards. Studying past eruptions through geological investigations and analyzing volcanic ash deposits provide insights into eruption patterns and their long-term impacts on climate and ecosystems. While the likelihood of a supervolcanic eruption bringing about global catastrophe is low, the consequences of such an event would be profound. By investing in research, strengthening early warning systems, and fostering international collaboration, we can mitigate these risks and build a more resilient global community. In conclusion, volcanoes are awe-inspiring manifestations of Earth's power and creativity, shaping landscapes and influencing climates. While they have the potential to cause significant regional disruptions and global climatic effects, the likelihood of them bringing about the end of the world is remote. Through scientific innovation, preparedness planning, and international cooperation, we can harness our knowledge to mitigate volcanic risks and ensure a safer future for generations to come.